Okay, let's take a look at problem 18 in chapter 5. The problem that we're trying to solve here, or we're trying to get more information about, is water shutoffs in residential housing. So this little table here represents the number of times in some period of time that um, people that occupied these homes. Now these are owner-occupied homes, so let's just put that up here. So we're going to differentiate between owner-occupied homes and renter-occupied homes. So I'm just going to, if I click this little button right here, that will merge those cells, and I'll just call this owner-occupied. Okay? And then these over here represent renter-occupied homes. So it's the same information, but for homes that are occupied by renters rather than owners. So we want to see if there might be some difference between the experience of owners occupying their own homes and renters occupying homes owned by someone else. So this is the number of times um, that that people that live in these homes experienced a water shutoff in the last 3 months. Okay, so 439 of these residents never experienced that. 120 of these residents experienced it 4 or more times in the last 3 months. So that's what this means. So we want to do this is a discrete variable because you either had a shut off or you didn't, and you either had it once or twice or 3 times. You can't have it 1.175 times. Okay, so we know it's a discrete um, variable. All right, so what we want to do is we want to make a probability distribution, which is a very simple thing to do. The first thing I'm going to do is I'm going to add up all the times that this happened. Okay, and I'll do it for both. And then I want to find out what percentage of the total times this happened, what percentage of the total times this happened, and that's basically the probability. So this equals this divided by the total. Okay? And I want that total to remain constant, so I'm going to use my dollar signs, and then I'm going to copy it down. Okay? So the probability of never having your water shut off is 22%. The probability of having water shut off one time is 55%. The probability of having it shut off 4 or more times is 6%, etc. Okay, now we'll do the same thing for renter occupied. Okay, so what we're creating here is just basically a discrete probability distribution. All right, now, so this varies a little bit, and we want to see if maybe, owners or renters, this happened more often. So we want to find the expected value. Um, how many times should a resident of an owner-occupied home expect that their water will be shut off in a 3-month period? So to do that, we're going to find the expected value or the mean of this variable, which we're calling x. Okay, so this is x. All right. All right. So we could do that. We could do that by multiplying the result by the I'm sorry. We could the result by the percentage. The result by the percentage, and in that way we could do a weighted average. But Excel, as always, makes things easier for us. So we'll just call this the mean, and we'll use the function equals sum product and some product, so this is the result, comma, and this is the probability of that result happening. And so the mean number of times that the water was shut off in a 3-month period was 1.18, also called the expected value. Let's call it the expected value. Okay, so if we were predicting, we would predict that any given resident would have their water shut off 1.18 times. Now let's do the same thing for renter occupied. So this would just equal, again, some product, the result, comma, the probability of it happening, close parentheses. Yep, put it in the wrong place, sorry. Equals some product the result, comma, the probability of it happening, so 1.22. So we can see that people in renter-occupied homes are slightly more likely to experience a water shutoff than are people in owner-occupied homes. Okay. Now it wants to know what the variance is in each case. Okay, now to calculate the variance, we want to know the difference between the result. In each case, we want to know the difference between the result and what happened squared. All right, and we want to take out the negative sign. We don't care if it's higher or lower than the expected value. We just want to know what the difference is between the actual and the expected value. So what we'll do is we will equal ABS, just means the absolute value. It just strips out the negative sign. So what's the absolute value of the difference between what actually happened, difference minus, and what we expected to happen? And I'm going to make that constant. And because we want the variance, it would be this value squared. And in order to square something, we do caret sign 2. Okay? So this is the variance in each case. Now if we want to find the weighted sum of the variances, then we just do sum product again. Sum product of the probability of what happened and the value of the variance. So it has a variance of 1.04. So let's take a look at the variance on this one. We'll do the same thing. First we'll compute the difference between what happened and what we expected to happen, the difference between this and this, the difference between this and this. But we want the absolute difference, so we put in there ABS, which means absolute difference, strip out the zeros, and it's the difference between what actually happened and what we thought would happen, that value squared, okay, which is caret 2. And I want to make this constant. Okay, and then I'll just copy them down. And then I'll just find the sum product, or the weighted average. Sum product gives us the weighted average. And it gives us the result times the probability of that result. So it's just this, comma, this. Okay, so that answers all parts of the question except E. We can see that these are owner-occupied houses. We'll just color this in a little bit. And these are renter-occupied houses. So we can see the difference. So we can say that this is the expected value for owner-occupied. This is the expected value for renter-occupied. We can see that for part E, renter-occupied housing is somewhat more likely to experience water cutoff. Get it? So that is a discrete probability distribution. Actually, it's two discrete probability distributions and its interpretation. That should do it.